Hello, my name is Don Belcher, and this is the introduction to COMSOL Multiphysics for chemical, biomolecular, biomedical, biological engineers. And what we'll be going over in this course is an introduction on how to use COMSOL Multiphysics to model the systems that you research to help predict how different chemical, structural, or control changes may alter the performance of your systems. What COMSOL Multiphysics is a software that helps you solve partial differential equations, and for some of you ordinary differential equations, to help resolve mass, fluid, heat, even electric and some materials transport. However, the majority of this course will focus more on the mass, momentum, and heat transport systems. So how this course will work is I'm going to be uploading these series of COMSOL Multiphysics introduction classes formatted as tutorials online. And then following each of these, I'll be opening a office hours type session where people will be able to come in and ask questions and get feedback on potentially troubles you might be having while trying to apply COMSOL multiphysics. So for today, we're going to actually be starting off with just a brief introduction to the interface in the COMSOL multiphysics suite. We'll be working on here is we can see over here is the COMSOL multiphysics window. I've already opened this up on my computer. This is COMSOL 5.5, but this interface has remained relatively unchanged all the way back since COMSOL 4.3. So don't worry exactly what version of COMSOL that you're trying to perform these simulations with. It'll matter a little bit later. We'll get into that closer to the end of this video. So what we can see here is when we open up the interface, it's relatively blank. At the top we have some buttons here, but really we have two options here, a model wizard or a blank model. And for right now, we'll just start off with a blank model. When we click on this option here, we're greeted with the full COMSOL multiphysics interface. We can see there's a ribbon up at the top of your screen, and then following that at the bottom you can see a series of windows. This ribbon at the top of the screen is similar to the ribbon for those of you that have worked with Microsoft Office products and how you can get to a lot of the core components of your system. There's of course your file where you can open, save as, save, look at preferences, things like that. And then going over the top we have model, definitions, geometry, materials, physics, mesh, study, results, and layout. And all of these are components of the software, and if we actually look in definitions, we see that corresponds to a much larger group here of potential definitions, geometry, materials, study, results. On the final point here is developer. We're not really going to get into that today. Developer's a bit advanced. We likely won't get over into that until most of the way through the rest of this course. The ribbon at the top of the screen is a great place to easily see a lot of the different options you have, but most of the work we'll actually be doing when we're working with this model is through the model builder window, this long column here on your left. And this is oriented like a file browser or an iTunes window with context-specific drop-downs and grouping. So we can see right now we have this untitled file right here, and in it we can add a component. Components are the basic element of the COMSOL model. It's what you're actually performing the simulations on. So we can add in here, let's just put in a 2D model for today. So here we've added a two-dimensional component by, again, right-clicking and adding the two-dimensional component here. We can see these context-specific things are great for adding in a whole host of different properties. For example, if I wanted to add a variable to our global definitions, I can click here and add in a variable. Parameters are another great thing. We'll be going over a lot of those in the class. For right now, I'm just going to be entering in two parameters here today. I'm going to be calling one L_W, and this is going to be 5. And then if I put a text in brackets, we can use that to assign a unit. So I'm going to say 5 millimeters. And then I'm going to call this the length. And then if I have a second one, I'm going to call this h_w. And this is going to be 10 millimeters. And I'm going to call this the height. So we can name things here in the parameters tab. I recommend, much like if you've worked with programming before, you don't want to hard code in numbers into the rest of your model. You want to use your parameters and variables tab to help define the parameters that you'll be using later on in the model. This can seem a little tedious at first, but trust me, this is what you'll want to do in the long run to help streamline a lot of your simulation work in the future. So if we go into the component now, we can see there are several different groups in here. If we look at the component here, the first thing we can look at is the geometry. Before we assigned our parameters as millimeter length units, so we can change that here to make sure the rest of our geometry aligns with that. So if we select length unit here, and we change this to millimeter, now everything is set to millimeter for our geometry. If we want to add a component to our geometry, let's say if we were to want to add a rectangle, right click, and then select rectangle, and we've now added a rectangle to the geometry. Going into that, we can see we have a width and a height function here, which we've already defined previously. And if we go to build selected, we can do it. We could put those in here. We can also adjust the positions. For example, if I wanted to shift the position just a little bit, I can do that here. However, I would again advise not doing that directly here. If we want to change the position, we want to use parameters, variables, and references to help define those. We'll look at actual applications of these in future models. Once we have a geometry completed, we can add physics. And this can be done, so let me back up just a second. Our geometry, the actual appearance of that, shows up on the third window on the right. This graphics window, we can see displayed our object in here, and we can also use various tools to navigate around. For example, by clicking the object, we can select it. We can also change our selection type. Right now I have it on selecting objects, but we can also select domains, boundaries, and points. For example, if we just wanted to select one of those boundaries, say we wanted to set a constant heat source on the boundary, we can select boundary, and now we just have a single boundary selected. Moving around here, we can use the middle mouse button by holding it down and then sliding in and out. We can use it to zoom in place. We can scroll around the environment. If we hold the right mouse button, we can slide around the environment. And there are also tools at the top where we can complete some of these as well. For example, a zoom box can be used if we want to just zoom in on a specific portion of our geometry. We can also zoom extends, which auto scales to the rest of the background. And there's a lot of other things we can do in the graphics tab that I'm going to hold off for a different point. And once we have our graphics, we can add physics. So if we go to the far right tab here, we have our physics tab. This is how you can add all the physics into your model. Right now I'm working with a version of COMSOL that's licensed by the Ohio State University. And this version has a lot of packages available. When you're working with the version you may not have access to all of these packages, but don't be too concerned. I will state if any specific packages are required, and for the most part we're going to be working primarily with packages that are either part of the base COMSOL license or are part of the COMSOL licenses that are usually available through biomedical, biochemical, chemical engineering departments at many universities. So for today, we're going to work with a relatively simple model here. We can just put in laminar flow in the Add Physics window, and we can click Add to Component 1. And if we give it just a second here, we now have our laminar flow added to our component 1. We can close out of this now, but if you need to get it at a different point, there's two ways you can bring back the Add Physics window. If we right-click on component 1, we can click Add Physics, and that will pull it back up. Alternatively, if we hit the Windows button on our top ribbon here and go to Add Physics, we can again pull that window back up. Generally though, once you've finished adding your physics to the model, you can avoid using them for the remainder, or avoid using that window for the remainder of your time. So now that you have your physics in the system, there are various things you can put in. For most physics, there are two things we want to handle. We want to handle our boundary and our edge properties. So this one has a fluid properties in the interior, initial values of the fluid in our box, and our wall conditions. So for our fluid properties, right now it's calling from materials. We don't have a material yet, so let's add one in. So we can add a material from the library. So for today we'll be doing that. So if we just right-click add a material from the library, and we look here in some built-in models, I just want liquid water to be in here. So I'm going to add liquid water to our component. So now this box here is our liquid water. And whenever we pull in the fluid properties, those correspond with the liquid water here. Looking at the initial values here, we have 0 for the walls, but let's add in some inlet and outlet conditions. So I'm going to put in a inlet condition here with, let's give a normal inflow velocity of 0.1 meters per second for demonstration. And then let's define a second one again, right-clicking the laminar flow to pull up the context menu, and then selecting an outlet condition. And let's put one on the top. And we're just going to set a 0 pressure suppressed backflow, just for showing how this works today. Once we have the laminar flow set up, we can move into the mesh. The mesh is what COMSOL works with. It's a finite element solver, so we need to set up our finite elements in the form of a mesh. Today we're just going to let COMSOL do all the work, and we're just going to tell it to build a mesh. And we can see after it's done that, we now have this mesh constructed here. You can see it's done a interesting job of defining a relatively coarse mesh at these two boundaries of our inlet and outlet. However, near our walls we have a much finer mesh defined. Now that the mesh is defined and everything's ready to go there, what we want to do is look at, now we have our physics, our mesh, our model, everything. We can add in a study. So up here, if we click add study, we have general options here in terms of either a general study. Also, there is now a cat here. So now it's apparently cat time. This is Claudette. She is very fussy and needs attention. Now cat time is over, hopefully. So looking at here, we have two options here. We have either a stationary or time-dependent study. For the sake of time today, I'm going to be doing a stationary study. By clicking in Add Study here, we add it to the model, and all it will do is solve for the stationary laminar flow conditions. Now that we have our stationary model here and are ready to go, everything ready to go here, we can right-click, again pull up the context-specific menu, and compute. And at this point, COMSOL will begin doing the work on solving the model. We could see down here it's setting up the solution time and the study, and we could see over here that our finalized geometry, its different properties, our mesh, number of degrees of freedom, and solution time. And this window here will tell you everything you need to know about how your model is running while it's going. This was a fairly simple model, so it didn't take very long to run. Looking over in our log here, I'm going to expand this window here. So log is a third tab over. We can see the nonlinear solver, how it ran, scales for different dependent variables, looking at the various iterations and how those solved. Here, again, we're working entirely with default settings. We'll go over more of what kind of settings, what kind of selection you should do to help your model. We can look at different, here in the results tab, we can also look at different properties of the system. I'm going to make this a bit smaller now, minimize our add study or close our add study and add material window so we can get a little more view of this over here. But we can also, apart from velocity, we can also look at pressure gradients. You can add in your own results with a 2D plot group and look at other components of your system. Looking at other different settings. So here, once we've added in our plot group, we want to add a surface in there, and we've already looked at velocity. So if we pull up this context menu here, in our context menu, in our model, in our component, in our laminar flow group, we have, for example, we've had our velocity field, but let's pull up our vorticity field to see what that looks like. So I'm going to add in a vorticity magnitude field here, and I'm going to plot it. Okay, nothing too exciting, but that's essentially how you added it. So with that, we've gone over how you the basics of going through the interface on how you add a component to your model, add in a geometry, add in some physics, and this is mainly for an introduction. I encourage you to try to play around with some of COMSOL yourself, but with next lesson, we're actually going to start getting into actual applications of COMSOL, using it for various systems. Thank you, and have a great day.